So the first thing we see today across the space is that cross-chain messaging is operating at a massive scale. These screenshots are from the homepage of Wormhole Scan, and a few numbers pop out to us. Wormhole has processed over 1 billion messages all time. In terms of cross-chain token transfers, Wormhole has facilitated the transfer of nearly $42 billion of value cross-chain. And looking just beyond this screenshot, Nikhil actually did some quick analysis on the aggregate volume of interop protocols, and he found that in total, interop protocols have processed over $70 billion in value all time. So it's definitely cool to see that Wormhole makes up a large percentage of this multi-chain volume. But the cooler thing that this actually shows us is that cross-chain messaging is being used frequently, and it's being used to transfer a lot of value. And as a result, it's reached an impressive scale. The second thing we see today is that interoperability protocols have actually paved the way in terms of security for the entire blockchain space. Generally, interop protocols have the largest bug bounty programs, and they're also the most audited out of all crypto protocols, sort of setting the standard for this transparency and getting multiple audits done for new product features because of the value that they do secure. But doing a quick search across the top interop protocols showed us that on Immunify at least, there are over $20 million in bug bounties being offered by the top interop protocols. We looked through the security programs of those protocols and also found that in total, they've had over 60 audits done between them. Wormhole with 16 and counting. The NTT framework itself actually having had 6 audits done on it. We were able to actually find all the audits that were mentioned as well, because it's become a standard and expected practice to make these audit reports and mitigations to bug findings publicly available. So we see this as pushing the whole space really forward. And in what we actually think has been an interesting development, the crypto community itself has started to develop standardized security frameworks through which to evaluate interop protocols. One example of this was the Uniswap Bridge Assessment Report last year, which was produced by the Uniswap Bridge Committee, which is a committee of independent researchers from some of the top independent security firms across the space, evaluating the security of various interop protocols across a set of very clear criteria. The criteria themselves are all available to check out in the Uniswap Foundation's archives and online. I believe there are links to them in a few places. And the framework itself is actually extremely comprehensive. I would recommend anyone interested in sort of OPSEC or how those or how these types of protocols are evaluated to go and have a look at it. It's like a big spreadsheet with a lot of interesting parts to it. And the cool bit about that was actually Wormhole was found by the committee to be the only unconditionally approved and most secure protocol out there. So it's looking at all sorts like crypto economic security, how it's validated, where the infrastructure is run, how it's hosted, how keys are managed, etc. And we do expect another similar assessment to happen again this year. And we were excited to see the results of that next one. But as a result of this, most interop protocols do implement a very standard set of security features. So for example, it's the baseline expectation today that an interop protocol should use a sufficiently decentralized set of validators that attest to messages. And anything less than that at the moment won't get you very far in this business. The third thing we see today is that cross-chain messaging is just everywhere. The use cases for interop have exploded, and it's being used for all kinds of crypto protocols. So the ones you see here, and I hate to put "and more" at the end of this, but I have to because there are so many more use cases. And another way of saying this is every crypto protocol is now thinking multi-chain. So enter Wormhole native token transfers, or NTT for short. NTT is an open framework for seamlessly taking tokens multi-chain. When you use it, you preserve ownership over your token and the entire framework that you've deployed, upgradability over your token, and customizability of your token. NTT also backward integrates with any kind of token. So that means you can preserve the custom logic for your protocol that's built in directly to your token already. So for example, governance, rebasing, or restaking, liquid staking, stable coins, and even NFTs. And this is a very important point to emphasize, which is that NTT is not a token standard. It's a framework that is open source, flexible, and composable. Since it's open source, anyone can use it. The out-of-the-box framework is very configurable, and it can integrate with any kind of governance process. We'll also get into all the various things that you can configure in some of the following slides. And another benefit of being open source and having standardized interfaces, configurable parameters, and the ability to add custom payloads is that it's composable. You can integrate NTT directly into other DeFi protocols. You can also build on top of NTT if needed to add features that might be specific to your use case. So to say it again, and say it with me this time, NTT is not another token standard. NTT is a permissionless and configurable framework designed for multi-chain token transfers. So how can you use NTT? How would you use NTT? It lets you transfer new or existing tokens. With new tokens, you can deploy in a pure burn and mint model. So in this model, when you perform a transfer between a source and a destination chain, your tokens are burned on the source chain and minted on the destination chain. This happens every time your token is transferred between different blockchain platforms or frameworks. This is the purest kind of multi-chain token that you can have because you maintain one balance across all of the chains. The current existing supply that's minted across all the chains always reflects your total supply. That said, there are lots of existing tokens already out there. Not all of those implement a burnable function, and not all of those can also be upgraded to implement a function for them to be burnable. So if you have an existing token, you can make it natively multi-chain as well via what we call the hub and spoke kind of model. In this model, you have a hub chain or a home chain where the existing token that isn't going to be upgraded to be burnable lives on. And when transferring out of the hub chain, the token is locked when it's transferred out and then minted on the destination chain you want to go to. When then transferring between those destination chains or spoke chains, it implements a burn and mint mechanism. When you transfer then back to the hub chain, it goes via a burn and unlock mechanism. So tokens will follow burn and mint between all of the spoke chains, and then they'll follow a burn and unlock when transferring back to the hub chain. In this manner, the hub chain will always maintain a canonical balance of all the token supply as well, while the tokens are then locked and minted out of the hub when transferring to any destination spoke. And it's also important to note that these aren't the only two options that you can pick from. They're just the most common options that we're seeing. NTT is very flexible, so if you do have any unique requirements for your token, you can always reach out directly to Wormhole contributors. And we'll share our details after this so that you can get directly in touch with us and we can chat on how to configure it to fit your use case or answer any further questions you guys might have. And as I mentioned previously, NTT has been specifically designed by us to be a configurable framework that protocols can use for the long term. The contracts are both ownable and upgradable, so protocols have full sovereignty over their deployment. And this also enables very important administrative and security functions to all be gated by whatever your protocol governance structure is. Via governance, you can configure exactly the right level of security that you need. You can set access roles, for example, designating the ability for someone to pause the contracts separate to who owns the contracts, enabling, for example, quick reflexivity or reactivity if those contracts need to be paused, and then having an owner then be able to then unpause them later. You can also set rate limits. NTT allows you to configure directly on-chain on the contracts themselves inbound and outbound rate limits for every chain that you've deployed to. This is arbitrary per chain and also over arbitrary time periods. So you can select to have certain numbers of tokens be able to come into a chain over a certain time period and also to go out of a chain over a certain time period. This can be really helpful when you are deploying to new chains and you would like to potentially limit the risk or introduce, for example, like training wheels, for example, onto a new chain that you might be deploying to. What's also cool is that this comes with some defense in depth security features, which I'll also go into after this, that are enforced by the Wormhole network. So as I mentioned, you can also pause the contracts to stop all new outbound transfers. And you can opt into what we call global accounting, which is a token balance integrity checker enforced by the Wormhole Guardian network. In addition, you can also freely configure other verifiers, whether these are custom verifiers that you maintain or other third-party verifiers. By verifiers, what I mean is the network that's giving the attestation of validity of that token transfer. So for example, NTT ships with Wormhole as a default verifier that you can use out of the box. You can also elect to use other verifier implementations that might be out there, or you could look to develop your own. And a verifier could be any process at all. So for example, if you have a regulated asset, this might refer to some off-chain function, or it could refer to some smart contract as well, to add extra custom business logic into any one of these transfers. And additionally, among these verifiers, you can set threshold attestation requirements. I'm going to dig into these security features a little bit more because there's a lot in there, and I really think that they help NTT stand out. So for us, security is our lifeblood. We bake security into everything that we do, everything that we build. NTT is no different. It offers defense in depth security that's completely configurable and helps it really stand out. So as I mentioned, there's the rate limiting. You can configure inbound sending limits and per chain inbound and also outbound limits. We, as the Wormhole contributors, also have a lot of experience working with these security features, rate limits specifically among them. If you set rate limits, you need to prepare for the user experience of being rate limited. So we built a queuing mechanism directly into NTT so that users who get rate limited can still have the confidence that their transfer will go through after the capacity opens up again. And remember, this is directly configured by you as well. The global accountant is probably one of my favorite features. It's enforced by the Wormhole Guardian network, and it basically ensures that you can never transfer more tokens out of a blockchain platform or ecosystem or chain than the amount that's been transferred in. So it enforces supply balance invariance. Let's say that you've expanded to a new chain, you've set some rate limits, and you have 1,000 tokens on that chain. Let's say for whatever reason, this chain gets compromised and something happens on that chain. It will never be possible to transfer more than 1,000 tokens out of that chain ever. So it's basically a balance integrity checker that works across every chain. And these features, together with the access controls that I mentioned around, say, pausing functionality, already cast a wide safety net of defense and depth security that protocols can all benefit from. But we also decided to go one step further with NTT security. We looked across the entire space. We looked in depth at all the other frameworks that were out there, or standards as well. And when we think about permissionless systems for the long term, we realize that those systems should not have lock-in, vendor lock-in specifically. Therefore, with NTT, you can freely manage adding or removing additional verifiers. These verifiers can be custom verifiers that enforce your own protocol rules, or they could be other third parties, such as other verification networks. And between these verifiers, you can also, this is another custom feature for NTT only, you can set custom M of N threshold verification requirements. So, for example, you can set 2 verifiers with a 2 out of 2 threshold, meaning that both verifiers need to both attest to the message for the transfer to successfully go through. But if you wanted to, say, avoid liveness risk of one of those verifiers going down and disabling transfers, you could set 3 verifiers with a 2 out of 3 threshold, or 3 out of 5 threshold, for example. So this is something to consider when looking at the future proofing of these kinds of protocols. And we're pretty excited to offer this kind of feature to protocols. It empowers projects to always have full control of the framework so that over time you can adjust it based on your own product evolution or the broader evolution of the crypto ecosystem. And as we know, there are so many factors to consider there. Everything from new verification systems, regulatory developments in different places, different spaces and areas. So there's a lot to consider, and you need to be future-proof, adaptable, but above all else, you need to have security at the core. It really has to be fundamental. So we really view having complete control over your own stack as non-negotiable. So that was one of our sort of guiding beacons in building NTT to accommodate for this, giving you a battle-tested framework with all of our knowledge and everything we know poured into it that you can then take and use in a safe way to facilitate your multi-chain journey. Going beyond just the NTT smart contract framework, NTT, like all other Wormhole products, will benefit from the full power of the Wormhole stack. The Wormhole contributors have built an encompassing suite of products to make going multi-chain a simple and safe process. This is our whole stack that you benefit from when you integrate NTT. We know that thinking multi-chain can be complicated, so we've worked hard to abstract that complexity away while still empowering you to tune your integrations. So NTT is integrated into this suite of products. Wormhole verification underpins the protocol. It ships out of the box with Wormhole as a verifier. It's provided by the 19 Wormhole guardians, who each attest individually to cross-chain messages before they're considered valid. And in addition, Wormhole contributors are hard at work building zero-knowledge verification mechanisms as well. This is really exciting. We also recently announced a partnership with AMD for hardware acceleration, And we brought on some of the premier ZK teams in the space to help us develop proving systems and algorithms and light clients that are going to work on this. Those teams include Succinct, Lurk, and Zpoken as ZK contributors to Wormhole. This is something really exciting that's coming down the barrel. Wormhole Connect is also a UI widget that anyone can easily pull into their own front end to access the entire Wormhole ecosystem of projects. Connect is integrated with NTT, so you can pull Wormhole Connect, configure it for your own token, and we'll show you how this actually works and enable your users to seamlessly transfer tokens via a UX optimized front end that uses the framework in the back. Any front end that already has Wormhole Connect integrated will also be able to leverage the new NTT functionality that's integrated today. Wormhole relayers also greatly improve the user experience of cross-chain messaging. We are super proud of the fact that we have a decentralized relay network that efficiently and effectively does the last mile delivery and execution of the message from point A to point B. So there's a whole slew of different relayers that you can consider. But when sending a message, users or protocols are basically able to pay upfront for that delivery to the destination chain. And there's a whole different set of flavors that can be set up with relayers. We offer out of the box, we offer standard relayers, there are specialized relayers, and integrators can configure their own relayers, for example, to pay the gas fees on behalf of users. And on top of that, Wormhole Scan is an explorer for Wormhole messaging that's been built by Wormhole contributors, and right now it supports displaying transfer details. Soon it will support displaying NTT transfer details in addition to this. So the combination of Connect, relaying, and Wormhole Scan enables projects to make transferring tokens with NTT enjoyable and like a one-click experience for users. So we're really excited
to announce. Just a quick heads up on timing. We've got about probably 4 or 5 minutes to wrap this.
Gotcha. Nice. So handing over to Nikhil very shortly. I'll just announce the protocols that are building or have already built and released. These are some of the protocols. We've got Wormhole, of course, Lido, EtherFi is launching very shortly with EtherFi, the governance token, Phantom with USDCE, Jito's Sol, and Stakewise is OSETH. And with that, I will hand over to Nikhil to explain the architecture here and go into a live example.